All right. Hello, everyone. I'm Bernd, and today is day 10 of Advent of Code. So today was about a display and a CPU, and we gave them a list of instructions, what is those. And there's only each instruction is one of two kinds. So either there's no operation, which does nothing, or there's the addition, which adds the corresponding value to a register, to the one register we have. For each instruction, we also know how long it takes, so the no operation takes one cycle, and the addition takes two cycles. Now for the first part, we pretty much want to know what's in the register at certain times. So how can we solve that? So of course, we need to first read the file and split it into lines. And then in order to get the register values from the instructions, we have this function. So we're told that at first there's a 1 in the register, and then we go through all the instructions, and we also know the current value. And then we want to figure out the value after the instruction. So if the instruction is no operation, the value afterwards will be the same, and we append that to the list of register values. Otherwise, if it's, for example, like this line, we parse the addition value out of it, and then we know the value after will be the current value plus the addition value. But we also know that this operation or instruction will take two cycle steps. So during the first cycles or step, there will still be the current value in the register, and only afterwards, after the two cycles completed, the value after will be in the register. So we have to append something to the register values twice. And we always, in this case, append the next value to the register values. So we also append the next value for the very last instruction. So in order to get the result, we return like all but the last register values. Okay, so we can check that this is correct. So we have two test inputs. One of them is this small program, and we also told that this has the following values saved in the register. So it takes 5 operation cycles in total. So no operation is 1, and the other 2 are 2 each. And this will be the values that are in the register. We can quickly run the test to see if the get register values function works, and that looks good. So in order to solve part 1, we're told that actually we care about the register at specific cycle numbers. So there will be 20 and 60 and 100 and so on, always adding 40. So we do while the cycle number is legal, less than the register value length. We get the current register values. So since the list is 0 index and cycle number start with 1, we need to subtract 1 there. And then there's like the signal strength is defined as the cycle number times the register value. We add that to the solution, and in the end we return the solution. Again, we can test this on a bit larger test input, and it gives us the right solution, so that looks promising. And yeah, we can also run it on the real input, and it gives us the right result. Okay, so for part 2, we're told the register values are actually used to draw pixels on a display. There is a sprite given, which consists of 3 of those number or hash signs. Then at each time step, 1 pixel is drawn, and its value depends on the position of the sprite at that time step. So if the sprite at any time is at the current drawing location, a number sign will be drawn, otherwise it's a dot. How can we do this? If we have the register values, we want to get the pixels corresponding to those. So we start with the pixel and empty array, and we keep track of the current drawing column. And then we know that the sprite position is always equal to the register values, the center of the sprite position. So we go through all the time steps and look at the sprite position. So the sprite pixels will be the sprite position -1, sprite position, and the sprite position +1. And then if the current drawing column is in the sprite pixels, the next the pixel we draw will be a number sign, otherwise it's the dot. And then we update the drawing column. So if it's at the end, it will be 0 for the next iteration, otherwise it will just move on forward. Okay, we can quickly test this getPixel function. So we know for our test input, this will be the test output lines. So we can just put them all into one line and then compare them to the output of the getPixels function. So if we run this, turns out we get the same output, so that's nice. So having the get pixels function, we can also solve the full problem. So we will use the lines and get the register values from them. Then we get the pixel values, and then we draw the lines corresponding to the pixel values. So we just iterate through the lines, and then always index the pixels at the right positions and print those lines. And then we'll have to look at the output and see and check the letters, and that will be our solution. We can also test the solve part. So if we run this, it will actually print us the correct grid. And yeah, when we run it on the input, we will get again such a grid, and then we have to stare at it and figure out the letters it spells, and that will be the solution. Okay, that's it for today. I hope you enjoyed today's puzzle. Best of luck for the future, and see you around.